So in the last two videos we were looking at partial fractions. In the last one I showed you how to use the cover-up rule. In this particular video we're going to have a much more complex fraction to work with. So let's have a look at that. That's 5x squared plus 7x plus 8 all over, and here comes where the fun starts. X plus 1 x squared plus 2x plus 3, and immediately you should be detected that there is a quadratic on the bottom here, and because there's a quadratic at the bottom, the partial fraction is going to look slightly different. So the first part's going to be exactly the same as you've seen before, a over x plus 1, but in the second one we have to do an order lower than the denominator. So if I just draw the denominator in first, or write it in first, so we're going to have x squared plus 2x plus 3. On the top I need to have an order below that, so it's going to be bx plus c. And if this was x cubed plus 2x squared plus 2x plus 3, then on the top I would have had to have an order below that, would have been bx squared plus cx plus d. But in this case this is all we need, and as you can see there we have three unknowns. We've got a, we've got b, and we've got c. So the first thing I want to do to try and simplify this is to multiply this bottom out into this side here, which will flatten this equation, and the result will be 5x squared plus 7x plus 8. And because we're multiplying by that denominator then is cancelled, and on the right hand side I'm going to have a into x squared plus 2x plus 3 plus bx plus c into x plus 1. And if you have a quick look at that, you will see that the x plus 1, when we multiplied across, this x plus 1 cancelled that x plus 1, leaving me with x squared plus 2x plus 3. And on this side the bx plus c cancelled out the x squared plus 2x plus 3, leaving me with just the x plus 1, which is where I've got the x plus 1 here. So, good. So what I'm going to do now is I'm going to make, x become equal to minus 1. And then I'm going to plug that into both sides. So everywhere I've got an x, I'm going to make it x equal to minus 1. And you can do the sum yourself, so I encourage you to pause the video at lots of times and do these sums. The answer is going to be on the left hand side. I'm going to have 5 minus 7 plus 8 equals a into 1 minus 2 plus 3. Now I've lost the b, and the reason I've lost the b is because when I made, let's just change the colour here, when I made x equal to minus 1, when it went into this equation here, it rendered this equation as a 0, which meant that anything multiplied by that 0 was going to equal to 0, leaving me just the a into x squared plus 2x plus 3. Now that I've got to that point here, my a should be fairly simple. The left hand side of this is going to be 6, and the right hand side is going to be 2a. Therefore, a is going to equal 3. Good. So we're well on our way now. Now we need to find b and c. So I'm going to pick a different figure for 0. So now I'm going to say make x become equal to 0, and do exactly the same thing again. Plug that 0 into this equation up here. You see, anywhere I've got an x and I put a 0 in it, it's going to equal 0. So really on the left hand side, by plugging that in and making that 0, then I get 8 on the left hand side equals 3 times 3, because we know that a is 3, so there's a. So 3 times 3, because I end up with that 3 there, because that's 0, that's 0, that's 3. So I end up 3 times 3 plus c times 1. And that 1 comes from that one just there. That's where that 1 comes from, that one there. So I've got c, because that x there is a 0 and that x there is a 0. So I've got 0 plus c times 1. So that's where I get that from. And actually, again, pause the video, but you should find, therefore, that c equals minus 1. So now the final thing I need to do is to find b in, oh, I'm going to change the colour, why not? So in order to find b, I'm going to say that x, so I'm going to make x become equal to 1. Now in this case, because I know what a is and I know what c is, I can make x now any number, because you could always find the figure for c, but 1 just makes things an awful lot easier. So therefore now I've got 5 plus 7 plus 8 equals 6 times 3 plus b minus 1 times 2. And you can do the sums yourself. You'll find that that comes to 18. 3 6s are 18 plus 2b minus 2. And the bottom line for this is that b is going to equal 2. I'll just give ourselves a little bit of room there. So now I've come to the point where I've got a, b and c, so I should be able to rewrite the original sum with the partial fractions now complete. So I've got 5x squared plus 7x plus 8 all over x plus 1 x squared plus 2x plus 3 equals 3 over x plus 1 plus 2x minus 1 all over x squared plus 2x plus 3. And as you can see from that, just through some simple algebra, I have been able to solve the partial fraction of quite a complex starting point. That completes this short series on partial fractions.